All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are doing something that I'm pretty excited about. We are doing our very first webcam stream, though it's more of a breadcam stream, as in breadboard cam. And to be fair, or to be honest, it's probably not my first. Well, okay, you know what? Actually, yeah. So, as man, I just ruined my own intro. I don't think I ruined it though. Anyways, okay, no. So today we are doing something that I'm excited about, and me messing the entire intro up should probably tell you how excited I am about this, and also a little bit nervous in case something goes wrong, because we have breadboard cam. Um, for the first time as a VTuber, I'm doing webcam. I guess this counts as more of a hand cam stream. My hand might, occasionally show up. Um, the main focus of the camera is supposed to be the breadboard because that's where I'm setting up the circuit. So we are gonna be doing some ESP32 um, Rust projects. Uh, well, not entire projects. Just we're gonna be playing around with ESP32 circuits using Rust, and I'm glad that I managed to set this up because I had to prepare a space where the camera could look, and the space had to be close to me. It's not immediately close to me right now. Like, I mean, I would have to move away from my mic to get access to the breadboard. So in that aspect, it's not exactly close to me, but it's still kind of close. So anytime I need to set up a circuit, I can just uh, move the breadboard off cam and set up the circuit and then bring the breadboard back there. So this way, at least, the cam is still showing up. Um, Also, additionally, I have, hold on. Yeah, I have this box with a bunch of components and jumpers, and mostly what I'm going to be using from this is the LEDs and resistors, because currently there are two LEDs being lit up, and I wanna I wanna set up a new circuit where there's three LEDs, and I'm gonna create a sort of thing where it's lighting up one LED at a time. I want to see what that entire setup looks like. Yeah. So far, everything seems to be going well. I had to fiddle with the settings, the webcam settings. I had no idea that high exposure actually affects the frame rate of the camera. I had no idea that that's the case. I only realized it once I cranked up the exposure and the frame rate just went to shit, and I was like, what is going on here? And fortunately I remembered that, oh yeah, the last thing I'd done was change the exposure. So let's try turning it back down and see if that helps. I turned it all the way down, not completely down, but I took it down to 500, which can further be taken down according to Gemini. I need to experiment with that and see if taking it further down will still keep the current setup well lit or not. So when the frame rate went to shit, I asked Gemini, hey, what's the situation here? Initially, I was doubting whether it was the video format that I had chosen, because OBS gives you a couple of different options for video formats, and it had already selected one format, but then I purposely changed it to H264, just in case, that helps, and also because that's the one that I've dealt with in various situations. And then shortly after that, oh, I also cranked up the resolution. That was another thing with the other video format that was selected, which was, I think, no, YUYV, and then some number. I don't remember exactly what it was. With that selected format, with that format selected, I didn't have too many resolution options. I only had like two, and one of them was something close to 640 by 480, and the other was close to 800 by 600. We can say it was something, not exactly those numbers, but something within that range. Um, what was I saying? Oh yeah, so I was only getting those options for resolutions, and once I changed the video format to H264, then I got more options. So then I cranked it up to 720, and I'm wondering if I should take it down, though I don't think it's going to impact that much. The latency doesn't seem to be that badly affected. The only thing I would be worried about is um, slightly more CPU usage, slightly more RAM usage, because 720 would be higher than whatever the lower version was. The lower one below that, I think, was actually 800 by 600. But yeah, I went for 720p. There was also the fact that I so something I had to take into account was the fact that I've cropped this image, or I've cropped this video. This is not being like this is not the entire thing that the webcam is seeing. I've actually cropped it, and the reason for that is um, because of the way that, like, the where I can place my webcam in terms of making the webcam close to the breadboard. Where I can place the webcam is, it's kind of limited. So I did the best that I could, and I made sure that the breadboard is being captured, and then I just cropped everything else out, and that's how the entire thing is being captured. So I feel like if I'm capturing the entire thing in 720p versus 800 by 600, I think 720p is going to give me better image quality. I don't think I should go up to 1080 because that's probably going to slow things down. And it might not even be necessary. I think this looks decent the way it is. But yeah. I have to play around with the settings. There's a bunch of settings in there. I turned off autofocus. I had to play around with the focus settings as well. I didn't want to set the thing to be autofocus, because then it's going to be randomly like blurring, and I don't want that. So just a fixed focus point is perfectly fine, because I'm not really moving this camera a whole lot, and even the entire setup, it's going to be at a fixed distance from the camera. Another thing is the exposure. I've set that to manual. I've set it to 500, but according to Gemini, um, that would probably also introduce a tiny bit of latency. So if I take it down to 150, that should give me a decent frame rate. But I mean, for the time being, the way that this is right now, it's not that bad. I feel like if I take the exposure down any further, it's going to really darken things, because to show you what it looks like I don't know how good of an idea it is to do this on stream, but I'm going to turn the light off and then turn it back on so you guys can see the difference. So as you can see, it definitely makes a difference. It definitely helps. having the exposure at that point. What I need to check is if I turn the exposure down from what it's at right now, is the image going to become darker or is it going to remain the same? Because if it does become darker, then yeah, I'm probably going to leave it at 500. But if it remains the same, then I guess that's an easy win for me. So I'll be getting a better frame rate just by turning the exposure down. But there's a lot of settings that I need to look into. For the time being, I don't think honestly, I don't think I'm going to be changing the majority of those settings because there's a bunch of other stuff in there like zoom and pan and tilt. I don't need any of those things. I don't need to change any of those things. I would much rather have all of that be at the default. And there's a couple of other things like, wait, why did the light just go off? I don't know why the light just went off. Okay. And yeah, holy shit, dude. I'm glad that I found this light. Um, I found this in like the living room. It's I want to say USB powered, but I'm not powering this off of a USB. I'm powering this off of a phone charger. I don't think it's a good idea to power this off of a USB anyways, a USB port. I need to be careful not to accidentally plug a USB port into this because these are bright LEDs and this thing is probably going to be pulling a lot of current. So I don't want to accidentally fry one of my... Holy shit, that's such an easy mistake to make. I need to be so careful. That's crazy, dude. Okay, okay. So here's what we are doing today. Okay. And I don't know if the next few streams are also going to be ESP32 streams because I'm kind of excited now that I've finally set up the webcam. And yesterday we finished re-setting up, if that's even a thing, the ESP32 Rust toolchain. We checked and made sure everything is working. Right now, live, I can give me a second. Oh yeah, I need to open up my stream on my phone just to make sure that I have the chat open. Okay, so what I can do now is change the code here. Okay, so let me comment this out and then run. So this is gonna... Wait, did I exit? Yeah, I exited. Okay, so this is gonna compile, and now you can see it's only the red LED that's blinking. By the way, there might be some time sync issues between when I speak about something and when you actually see it popping up because something I definitely wanted to do is make sure that the webcam is connected to my Ubuntu desktop and not to this laptop that I'm currently streaming off of. So the the webcam feed that you're seeing is actually part of the RTMP feed. It's not part of the OBS setup from which I'm streaming to Twitch. It's part of the RTMP feed. That is this feed. Basically, what's basically the entire, the Kitty terminal with the Matrix Rain and the two Tmux windows, and now the webcam feed as well. I wanted to make sure that the webcam feed was part of that. First of all, to kind of not have the load be on my laptop, the load of the webcam capture be on the laptop. And second, so that I'm sure that the webcam feed is off whenever I'm not streaming, because I'm kind of paranoid about that. More so me accidentally, you know, forgetting to cover the webcam. Also, this place that I've set up now, this is actually on a laptop. The surface that this breadboard is on and that light stand is sitting on, this is all on a laptop. I haven't decided if I want the background to be black or white. I need to experiment. I need to do some research and figure out. I need to figure out what looks better. Well, okay, it's a good thing that I'm streaming right now, so I can probably take a look at this. What I could do is I could remove, give me a second. I can remove, so I have the breadboard currently on some tissue so that there's a white background. I can remove it and then there'll only be a black background, and then, you know, the breadboard has its off-white color. So we can see what that looks like. Okay, so that's what that looks like right now. I feel like that I feel like that maybe hides details. Yeah, I feel like that might be hiding details. We kind of want things to pop out, right? Um, and I feel like this darkens the image. I could be wrong. Maybe I'm looking at it the wrong way. Hold on, hold on. Let me put the tissue back there and see what it looks like. Okay. Yeah, dude, I'm not sure. Maybe it's not making that much of a difference. I kind of feel like there being a black background, it really darkens the entire, like, whatever is going on around the breadboard. So having a white background is much better. Yeah, yeah. I feel like having a white background is much better. Okay, so what did I do after yesterday's stream? I can't remember exactly because there was a bunch of research that I had done um about something else. I can't remember what it was. Um yeah, I don't remember. I don't remember what exactly I did research on after the stream ended. What was it? Was it the named pipes thing? Because, like, okay, I got to the point where I'm satisfied with what I do know about the ESP32 Rust toolchain, and I would much rather not dive too deep into stuff that I don't need to be diving too deep into right now, because that's going to waste a lot of time. If I'm being honest, it's going to waste a lot of time. Um, so the knowledge that I have right now, I feel like what I should do is maybe take note of the steps that I had to take in order to set up the ESP32 Rust toolchain. However, I believe the no-std training book, or just the not even the no-std book, just the ESP32, just the ESP Rust book. I think that book itself, it covers this pretty well. It goes into full detail. That's the book that I followed to hold on, let me open up my browser. How do I get to, I don't think I have the thing here. Oh, I have it here. So let me load this up. Okay, so this, right, while this is loading, let me just mention, dude, this is exciting for me. This is, we finally have, we finally have the ability to do electronics streams. So if I wanted, I could set up, I could start doing the Arduino examples. I think I do have a potentiometer. The thing is, I don't know if it's working or not. Because one of my previous potentiometers, I managed to solder wires onto it, but I think maybe the way that the way that I connected it in a circuit a while back, I might have fried it a little bit, and so one half of it works. I have no idea how that happened because I still don't fully understand potentiometers myself. Like when you're using them in an analog circuit, they're a little different than when you're using them in a microcontroller circuit. And in an analog circuit, you would in an analog circuit, you would just be using two of the pins, and right there you have a variable resistor. So then you can just, turn the knob, and you have variable resistance. You don't have to use all three. When you do use all three, it kind of serves as a voltage divider, and that's the point where I need to do more research because I don't know anything about voltage dividers. And was it voltage dividers or current dividers? Because with a resistor, you're limiting current. You're not limiting voltage. So this might count as a current divider, but then it's variable, so you can like control, how much current it gets by controlling the resistance. Anyways, I need to check, or I guess, well, oh, what I could do is I could also frozen. Wait, did we just lose? What just happened? What just happened? It seems like the stream crashed, but stream didn't crash. The thing disconnected and I think immediately reconnected. I have no idea. I have no idea what happened. Okay, anyways, so I need to learn how to aim the thing in a place where the camera can actually see. Hold on. Yeah, there. So that's the battery pack that I have. I can hook this up to a simple LED circuit and then additionally have a resistor in there and then also put in the potentiometer. So if I use a resistor and a potentiometer, then it's going to be, the LED is going to be getting much less current. So it's probably going to be really dim, but at least I'll find out that, whether the thing is working or not. Alternatively, I could also um, just solder wires onto one of the other potentiometers that I have. So I'll have like a brand new potentiometer because the last time that I tried to solder wires onto a potentiometer, it was before I got my soldering station. I haven't tried soldering wires onto a potentiometer after I got the new soldering station. So I was using my old cheap soldering iron, and it was basically one of those soldering irons where you um, hold on, I lost my train of thought. What was I going to say? Soldering iron. Yes, it was one of those soldering irons where it keeps heating up as long as you keep it plugged in, and there's no limit. So as long as the thing is plugged in, it's going to keep heating up, even if that ends up um, cooking your soldering tip, which is, you know, obviously a bad thing. So the way that I would have to solder with that was I would plug it in, and then once I feel like it's heated up enough, then I would plug it out. And usually how I would have to go about this is, okay, plug it in, wait for the thing to get to what I think is the right temperature, or the temperature where it can melt the flux or burn off the flux, and also then melt solder, get it to that temperature, and it's still heating up. It's actively heating up. So once I put the solder on there, then I have to go and heat up the component where that I'm trying to solder the stuff onto. And depending on what kind of what the situation is, maybe I have to put some solder onto that surface as well. And it was a mess. It was not it was not a well, okay, yeah, wait, let me finish. So once I somehow managed to, you know, solder something onto that surface, I would then have to immediately plug the thing out, or unplug. That's the word. I would immediately have to unplug the soldering iron so that it's not heating up anymore. Now though, I have a soldering station, which is great. Shout out to my family. Um, Now I have a soldering station, so now I can do proper soldering because I have something that actually um, it's temperature controlled. So you can set a temperature and the station will make sure that the iron remains at, or the tip remains at that temperature. It doesn't go beyond that. So it's going to keep heating the thing up until it gets to that temperature. And it even has a little blinking LED that'll tell you when the thing is ready to use. So yeah, I'm excited to start using that a lot more often. I've used it a few times so far. Something else that I learned in terms of electronics, or specifically in terms of soldering, was when I was doing research on what type of soldering tip to order. And I was really mistaken about the kind of tip I would require. Um, and at one point when I was placing the order for the tips, I accidentally placed the order for the wrong tip, but it turned out to be a good choice anyways because, oh wait, my OBS is freezing again. No, we're good. We're good. Okay. It turned out to be a good choice. I think it was the knife tip that I accidentally placed the order for, and it turned out that that is actually a good choice because it has an interesting design. First of all, it has like it's a chisel. It has a chisel tip, which is basically I believe it's called a chisel tip. It ends in a V. That's the kind of tip that it has. But it's also a little how do I even say this? Hold on. Um, I think it might be better to look it up. So what I can do here is this. I made this mistake the last time. Not gonna make that mistake again. Um, I think it was so this is the 900M series. 900M 900M and then something. I think it was TK or just K. The K stands for knife, I'm assuming. 900M tip TK. Let's look that up. Okay, yeah. This is basically what I was looking for. Let me bring it back. Yeah, this is the tip that I ordered. So as you can see here, on just look at any of these tips, they have like an elongated surface kind of thing. They have like a slant, and so you have some room to work with. It's not just like a point. The default tip that a lot of people use is like a conical tip. I used to think that that's the best, but apparently that's the worst because that's meant to be an all-round usable tip, but in reality, it's useful in some situations, harmful in a bunch of other situations, and because you're trying to use this for multiple situations, you can end up in a mess. This, uh, just a second. Yeah, this tip, the interesting thing about this tip is that I don't know if I can show it here, but you can see, let me, so you can see like the V. I don't know which one of these is the best to show you the tip. It's, I have no idea how I can show it, but like if you are able to pay attention to, is there like a close up? There is a close up here. So one of these, so one side of this, it has this kind of thing going on, right? You would assume that on the other side as well, it would be exactly this, but it's not. On the other side, it's this, but on one side, it has like a bevel sort of setup. It's not like completely flat. There's a bevel on towards one end. I have no idea how to explain this thing that I'm trying to explain, but that's useful in certain situations as well. So, anyways, I learned that yeah, this can be pretty useful, and since then I have started using the knife tip a lot more, and I'm gonna in my soldering practice I'm gonna be using the knife tip a lot more. Okay, okay. Now, I need to set up the circuit to have three LEDs, and we're not going to be diving into the Arduino examples today. Today, I want to play around with just Rust. Um, I want to see, you know, what we are able to achieve in terms of setting up logic for the ESP32. Shit, I've got a bunch of like electronics around me now. I need to be super careful. This what I've set up here, it has just added one more step to my streaming setup, and I feel like I'm going to be doing a lot more electronic streams because in the past I have mentioned that I wanted to do electronic streams. I definitely want to do robotics streams once I actually learn robotics. And in terms of the electronic streams, once I learn the basics of once I learn the coding side, because while I know Rust, I am not fully familiar with the ESP32 Rust API. So in terms of, let's say, a good example, let me go back here. A good example is this. This is a very simple example, right? It's a blinky circuit. Um, I had no idea that you would need to do this. You would need to, configure, you would need to run this ESP init thing. I had no idea you would need to um, initialize. the pin that you're going to be using in this way, in the way that we have initialized LED01 and LED02. So there are all these different ways of doing things. Other simple stuff like, LED01 dot set high. Yeah, that I can maybe take a guess that, okay, this is our pin, and in this pin, we're going to have so and so function. I need to learn this API and also learn about ESP HAL and embedded HAL, because my understanding, dude, it was interesting, and I feel like this is something that I should be putting more of my time and effort towards, rather than what I was doing yesterday, which was actually, no, you know what? Okay, I was about to say that I should be putting more time into this than what I was doing, rather than putting more time into what I was doing yesterday, which was looking into how the ESP Rust toolchain works. But no, I have a certain level of curiosity which has to be satisfied. Um, so it was definitely necessary for me to look into whatever I looked into. But I stopped at the right point because I'm now satisfied with what I know. There's definitely a lot more deep diving that I could do, but I don't think it's going to benefit me unless I have a very good reason to dive deeper into understanding what the toolchain uh, looks like, and what various tools are making up the toolchain. I feel like maintaining a certain high level understanding is enough. It's sufficient, and I should stop there and then divert my time towards, or rather spend my time on learning, the higher level stuff, the coding side of things. I feel like that's a much better use of my time, because that's what I'm actually going to be applying in my projects. Learning all about the tool chain all the way down to the metal, it's not going to benefit me nearly as much as, you know, learning all about the various libraries that are involved here. Like, for example, you have embedded HAL, which the idea here is interesting. Embedded HAL, it it creates an interface, or a bunch of interfaces that microcontrollers would be using, right? It hasn't created the interfaces for a specific microcontroller, just an interface that's for embedded devices. Then you can have embedded devices that would write their own layer, their own abstraction layer, which implements this embedded HAL. So that's, I'm assuming, where ESP HAL comes from, because ESP HAL is implementing embedded HAL, and embedded HAL sort of defines an API that would be common amongst a bunch of microcontrollers. Stuff like having GPI opens, supporting various types of serial communication. Maybe if there's Wi-Fi and Bluetooth support, maybe if there's any other sort of RF support, stuff like that. It the embedded HAL, it defines that API, but it just defines that there can be this kind of API, and then other microcontrollers can implement their own layers that follow this API. So they are essentially implementing embedded HAL, and then what we do is we use embedded HAL, and depending on which specific chip we are using, um, sorry, what did I just say? We then use these specific HALs, like in our case here, we are using ESP HAL. We then use these HALs, which are implementing embedded HAL, and depending on which chip we are using, there's going to be different functionality being provided. So all of that code has been written for us, and this is how you have like a very standard interface, standard behavior, which I find really interesting, because this gave me a different way to look at things. I've done a horrible job of explaining what this is, but like, this gave me a different way to look at things. this also kind of made me understand and appreciate the embedded graphics layer, because that's another layer that essentially provides an API and various types of functionality for embedded graphics. But here's the thing, it is providing you with the API and functionality to do things with data, but it's abstract. It's conceptual. So it's like, well, no, not conceptual. It is providing you with the functionality, but that functionality, it has like the way that that functionality is going to be implemented on specific hardware is actually hardware specific, right? But then you have certain types of very standard functionality, like how to draw a square, how to draw a circle, right? Embedded graphics, it defines those kinds of functions, and also various types of API that various other API that you would be using in embedded graphics, but it defines this high level function, and within this function as well, there's certain ways of doing things. It implements that, because like drawing, it's not as simple as just creating a function that says draw circle. They have implemented the functionality for drawing the circle, but this is all data. I think I should I think that's a good way to put it. At this point, this is all just data. It is dealing with the data for you. So in terms of data on the software level, if you need to draw a circle, what's the specific way that the circle would be drawn on, let's say, a 2D grid? Embedded graphics, it has functions that do all of that stuff for you. And then you can write your own hardware specific implementations for how stuff is then going to be, this stuff that has already been like processed, how this will eventually be drawn on your specific device. Maybe you are trying to draw it onto a grid of LEDs, or maybe you're trying to draw it onto a TFT display, or maybe you're trying to draw it onto I don't know. There's one of the cheaper displays as well, which I should look into getting that. I think maybe I have one version of it. Yeah, I have one version of it. I don't remember the specifics around it, but the reason I am not using it yet is because I never managed to solder a header onto it. I didn't actually, it's not that I couldn't, I wasn't confident enough with doing it. And I'm glad that I didn't attempt to do it, because, dude, when you're dealing with these various types of modules on which you solder headers onto, you have to be quick and careful, because if you make a mistake, your mistake is going to be attached, your mistake is happening very close to the very next thing that you have to solder onto. And then if you make a mistake there, that's close to the next thing you have to solder onto. Headers are basically pins that are one after the other. So actually I can show it. I don't know how well I'm going to be able to show it, but give me a second here. Okay, so I'm going to bring it up to the camera right now. I'm placing a header, or a set of header pins, and an MPU 6050 module to show you what the holes look like in which the header pins are supposed to go. Okay, let me see what that looks like on stream. I have no idea. I have no idea what that looks like. Oh, actually, wait, let me bring up my OBS. Oh, okay. That yeah, I think that's satisfactory. So yeah, that's what it looks like. And because they are like one after the other, So you kind of have to do all of it in one line when you're soldering stuff, and doing that with a cheap soldering iron it wasn't gonna end well. I'm glad that I didn't do it. I decided to try and do soldering on one of those. I have a set of perf boards that I ordered. These are just boards that have they have like a grid of I can actually show that as well. Hold on. Shit, dude, now we have a webcam. I can show things. Hold on. Okay, so let me see if I don't know what that looks like on stream. Let me hold on. Hold on. Okay. Yeah, cool. So, yeah, as you guys can see, there's a couple of like on the other side, like when I flipped it, you could see like shining stuff. There's a bunch of like copper traces, and these are basically just like holes with copper traces around them, and so you have an entire grid of such holes that you can solder things onto, and you can make connections between them and stuff like that. This is great for like your custom projects if you are not able to if you're not able to do like PCB printing and designing and stuff like that. And this is actually great for prototyping as well, for your initial prototype boards. I'm gonna be using this for like a long time, a very long time. I do not have the ability to uh, make or print PCBs. Um, I don't have the machine to do that. If there is a cheap way to do that, I am probably not going to be able to afford that either. I cannot afford to get somebody to print my PCBs for me either. So I'm going to be sticking with this perf board method for a while. Wait, are these called perf boards or something else? Hold on. I don't want to get the terminology wrong. I believe these are perf boards. Give me a second. Yeah, these are perf boards. More or less. Though, okay, some perf boards actually come with breadboard type wiring. So like if you look at the breadboard that you can see on screen right now, um, if you look at the rows of, how do I say this? So if you look at basically, okay, breadboards, they have like a rail sort of system set up. So they use rails to allow you to connect multiple holes together, and that way you don't need to, solder things. You can just like connect. If you have, like for example, if you look at the way that I've connected things right now on the breadboard, notice how the resistor, one of the legs of the resistor has, like if you look at so there's two resistors on the board right now. You look at the left side of the resistor, the left leg of it, in that same row there's a jumper wire, and it's the same thing for the other resistor as well. So the reason I'm able to do this is because there's like a rail there, and this is how the design goes throughout the breadboard. You have like a bunch of these vertical rails. Well, depending on how you're placing how you have oriented maybe I shouldn't say vertical or horizontal. There are these rails that allow you to connect these legs together. Okay, yeah, I was supposed to change the wiring so that actually not just the wiring, I had to also place an LED in there. Give me a second. I need to take this breadboard off cam and set up the thing. And what I want to try to do is set up the Rust code to have a simple like 1, 2, 3 kind of timer. Um, so it'll be like, 1 second it's one LED, the next second it's the other LED, the next second it's the other LED, and so on. And then it wraps around as well. Okay, give me a second. Okay, now I need to grab a green LED and also a resistor. Dude, I'm excited to start doing projects with transistors as well. Though, okay, for this, I do need to move forward with, actually get started with. I say move forward a lot. Not that's not really a problem though. But yeah, um, I need to get started with that analog course that I had set up, where Gemini teaches me analog electronics using microcontrollers. Now that we have the webcam, holy shit, dude! Now that we have the webcam set up, we can actually move forward with that. I'm excited. I'm excited for that. Give me a second. Let me just do this wiring. Dude, you need to be so careful connecting things into a breadboard that has a microcontroller that currently has a program running on it and is actively being powered. You have to be so careful with it. Fortunately, I've like my stuff is very simple so far. I have no idea how I'm gonna go about doing things later when my circuits become super complex. Because legit, the best thing to do there is to just disconnect the power and then connect your thing back in. Another very risky thing is setting up the circuit and then repowering the or powering up the ESP32 again, but the program that's already on the ESP32 from before, that starts running, which is the default behavior. But then now your circuit setup looks different, so now you have no idea what's going to happen. And in that, split second that the program does run, you have no idea if something could happen to your circuit. So I guess we'll be learning about those complexities as well. Uh, we'll learn how to solve those problems once the problems actually occur. Right, give me a second. Okay, I'm not sure how to go about this. Um, yeah, I'm not sure what's a good way to set this up because, hmm, Okay. Um, you know what? The ground for each of these could be. No, okay, yeah. I mean, we could share the ground, but then, hmm, hold on, hold on. Oh, okay, okay, okay. I think I need more black jumpers because I like to assign darker colors to whatever is going to ground and lighter colors to whatever is positive, whatever is considered positive. Okay, I've got the man. I'm realizing now that this is leading to some dead air. Um, I mean, it is what it is. Give me a second. Okay, so I've got the LEDs set up. I need to now set up the resistors for them. Where did I place that other resistor? Oh shit, I lost the resistor. Oh, here it is. Okay, give me a second. Okay, so now for the time being, I can actually, yeah, I think we are good at this point because I've connected what needed to be connected to ground. I just need to connect what needs to be connected to um, the positive side. And I need to add another jumper, which I guess it can be another red wire or another white wire. Um, for the sake of letting it stand out, I'll go with the yellow or green one. I think I'll go with the green one. Now, one of these pins had uh, there was something that you were there was something I had to keep in mind about one of these pins. I can't remember exactly which one it was. I think one of them had like a floating state. I forgot what it's called, but like when the pin is floating, when you haven't assigned anything to it, it's still going to be putting out a bit of current. I forgot what that's called, but like in digital logic circuits, you tend to have this thing where you need to explicitly set it to high or low, because if it's in a floating state, then it starts to pick up noise from different places, and then you'll see some sort of signal being put out, but it's unintentional. Okay. I'm gonna put the breadboard back now. I've set up the circuit. Okay, so I don't know how visible that is. Yeah, I think you can see it. Yeah, I think hold on. Yeah, I think you can see that the blue LED is currently it's slightly lit up, not fully lit up. And that's because of the floating state thing. I'm actually going to look that up. Um, Gemini Gemini will be able to tell me exactly what that is. It had something to do with digital logic. We'll probably come across this at some point because I remember the same issue happening with one of the other things I was looking into. Um, I think it was the AND gate that the AND gate IC that I had. In that also, I was running into this issue where I hadn't explicitly set the state for it, or it wasn't meant to have like a state. And I mean, I can't remember exactly. There was a specific way to go about setting that. Oh, I think it's because I wasn't giving input to the thing that was supposed to be given input to, and so that's why whenever the IC was powered, it was putting out signals out of certain pins, which were kind of like unpredictable signals. And so you would get like if you would connect an LED to like, you know, show that this is 0 or 1 or on or off, the LED would start flickering. Hold on. Okay, I'm doing ESP32 projects on my breadboard. I connected an LED with a resistor to D5 on my ESP32. I haven't explicitly, oh, let me also mention Rust, ESP32 Rust projects. Explicitly told the code to do anything on D5. Um, Yet there's there seems to be a tiny bit of a signal on the pin that's causing the LED to light up. I remember something about, oh, floating pins. That's what it was called. Okay, okay, wait. I remember this um, being called something along the lines of floating pin or floating state. And in another convo, you had mentioned to me, no, in another convo where I had a similar issue with a CMOS AND gate, AND gate pin putting out signals, putting out unintended signals. You had mentioned that this also had something to do with the pin floating. Can you explain that again, uh, and what it is and why it happens? Okay, it sounds like you've run into one of the most common quirks in digital electronics. When a microcontroller's pin is in a floating state, it is essentially electrically electrically homeless. It isn't connected to ground or VCC. Here's a breakdown of why it happens and why your LED is reacting to it. What is a floating pin? In digital logic, um, we usually want a pin to be in one of two states, high or low. However, when a pin is configured as an input or uninitialized, in our case it's uninitialized because we haven't even initialized the pin yet. And actually in the Rust code, when we initialize the pin, we do specify the level, which is here, level.low. Okay. Um, However, when a pin is configured as an input or is uninitialized, it enters a high impedance state. Um, in this state, the pin is internally disconnected from the microcontroller's power and ground rails. Because the internal resistance or impedance is so high, almost no current flows through the pin. This makes it incredibly sensitive to its surroundings. Why the LED lights up? You might expect a disconnected pin to stay at 0 volts, but physics has other plans. A floating pin acts like a tiny antenna. Electromagnetic interference, EMI. Your room is filled with electromagnetic noise from Wi-Fi signals, power lines in the walls, and cellular signals. Why is that so hard to say? Cellular signals. Because the floating pin has such high impedance, even a microscopic amount of energy harvested from the air is enough to create a voltage on that pin. The physics of CMOS, the ESP32 and the AND gate you mentioned use CMOS, which is complementary metal oxide semiconductor technology. Okay, it uses CMOS technology. The inputs on these devices are the gates of MOSFETs, which are essentially tiny capacitors. A tiny stray charge buildups on a tiny stray charge builds up on that gate capacitor. According to Ohm's law, because the resistance is nearly infinite, even a tiny current, oh, the resistance is nearly infinite. So there's no resistance, and that's why it picks up the current very easily. Even a tiny current can create a measurable voltage. This voltage can hover right at the threshold where the LED just barely begins to conduct, causing a faint glow or flickering. Why it happens on the ESP32? When you power an ESP32, most pins default to a high impedance state until your code, in this case the Rust ESP HAL or ESP IDF HAL, explicitly tells the hardware to drive the pin. If your Rust code hasn't reached the line where you define D5 as an output, the hardware is just sitting there in its default state, letting the pin float and and pick up whatever static electricity or interference is nearby. This is interesting, dude. This is actually really interesting. I should look further into this. I've actually looked into this multiple times in the past, but I didn't really go too deep into trying to understand it. I usually stop at this point where I understand that, oh, this is a thing in digital electronics, and specifically with CMOS based tech, where you shouldn't leave a pin in floating state. So if you are connecting a pin to anything, you need to initialize the pin to something, to some sort of state. Otherwise, its behavior is unpredictable. And in this case, the unpredictable behavior is basically that it'll pick up static from anywhere nearby. However, I would like to recreate this behavior. I would like to not in the microcontroller. I would like to create a circuit that on purpose picks up electricity, picks up signals from nearby. I feel like I first need to understand how MOSFETs work. I haven't gotten to that point yet, because it seems like this whole charge buildup thing is happening because these things use MOSFETs internally, and I'm mainly working with BJTs. At first, when I'm going to be learning about transistors, I'm going to be mainly focusing on BJTs, which are current driven, um, while MOSFETs are voltage driven. And they both also fundamentally work differently. Okay, I guess that'll be a future project. For now, though, we are gonna initialize our third pin. Should I change LED to pin? I'm wondering if I should change LED to pin. What was it? 5? Yeah. Okay. So we, you know what? Okay, let's run this right now and see if it turns the LED off. Yes, it does. Okay. So when you explicitly set the thing to be low, then it actually respects the state. Okay, so in this case, what did we want to do? So I wanted a thing where, so for the time being, we are using our delay thing, which, from what I remember, is one of the unstable features. If I create a project that doesn't use unstable features, delay is not going to work. I don't remember where I'm supposed to be looking. Was it in ESP Where was this pulled from? ESP I need to go into the ESP repo and ask. I don't even know how the LLM is going to handle this, but like, let's see if the LLM handles it. ESP_HAL GitHub. In here, let me open up chat with Copilot. Okay, can you analyze the repo and tell me at what point did delay, no, tell me if delay is considered an unstable feature, and at what point did it become one? Also, can you tell me how to find out if a certain, this is a struct, isn't it? Delay is a struct. Yeah. How to find out if certain structs slash functions are considered part of unstable features. For the time being, I think I can look at my cargo toml and see if that reveals anything. See here we have ESP_HAL, we have unstable. So I'm assuming this acts as a sort of namespace, the features thing, because in order to bring in specific types of functionality in various crates, you do tend to need to include, the feature name. In this case, the feature is called unstable. I forgot what I was saying. Okay, I'm going to read Copilot's response. Is delay considered an unstable feature? No. The delay struct in ESP_HAL is not marked as unstable. Why did I think it was unstable then? No. There was something. Nope. There was definitely something that was unstable. Now I need to find out. What is a good way to look at the code? Maybe through TV. I'll open up TV and look at the files. Give me a second here. Okay. So we are in no-std training, which is where I was trying to be, I think. Intro. That's where, yeah, okay. That's where I was trying to be. So I can open up TV here. TV files. Um, yeah, okay. We can do intro slash src slash bin. No. Examples. No. Intro dfmt source. Oh, okay. Okay, yeah, this is what I'm looking for. So here, um, which one was it? It wasn't. Was it in Blinky? Blinky currently has. Blinky has missing code. Wait, Blinky has missing code. What about button? Uh, how do I open these up in NeoVim without? No, no, hold on. Let's what's going on in this window? No, that's a Gemini conversation. Though there's 14, window number 14 missing from here. So I can open the thing up here. Let's go into Scratch stuff, learning ESP Rust, no-std training, um, no-std training, intro. Okay, and then we'll do bat blinky slash source slash main.rs. I can probably open up multiple of these. Okay, set so and so as out. Did I like change this code on my own? I don't think I did. I really don't think I did, because if I had done that, then if I opened up Git UI here, I would be seeing some like changes, but there's no changes here. Hmm. I also just realized that when I was scrolling through the code in TV, you guys couldn't see that, um, because that is being hidden by the. Wait a second. Why is the. Hold on. Why does the feed look frozen? Damn, that's crazy lag, dude. Hold on. Hold on. Okay. That's better. So when I was doing this, there's actually a file preview being shown on the right side, but the way that I've set up the webcam is now occupying that section, so you guys can't see it. But what I'm wondering is why is Blinky empty? Let's do intro and then this. Okay, so yeah, I'm kind of confused because there was a there was a reason why I thought delay was unstable, because in the past I had this issue when I tried to directly copy the code from. Wait, I have the repo open here. Let me see if it's the same over here as well. I did not mean to open that. Okay, no, it's not. The code has been changed here. the code has been changed here. I need to pull this. Um, I need to pull this specific. How do I do that? I think I have to check out the commit. Yeah, I think so. I think I have to check out the commit. Let's go back and do git UI. I'm surprised it's not showing any changes here. It should be words. It should be showing changes because there's a git repo here. Um, yeah. It should be showing changes unless the code was never there to begin with, which I guess we'll find out over here. Let's check out this repo, this commit. Oh, we are currently on that commit. I don't get it, dude. Why is it not showing the code there? Or why is it not reflecting the changes? If changes were made, why is it not reflecting the changes? Yeah, that's confusing. That is definitely confusing because I'm looking at the exact same thing over here, and on this commit, this is the same commit. Oh, there might be a reset option under status. So if I reset, no, it's not. That's not working. Oh, there's reset here. Okay, it's reverting this, but reverting it to what exactly? And these are not the changes that I was trying to revert. No, no, no. Don't do that. I'm not sure. I'm not sure what. Uh, how do we unstage? Undo commit. Okay. To unstaged. Unstage all? Does that do it? Oh yeah, okay, that does it. Unstage all. That's what I was trying to do. Now, if I have checked out to this, let's just quit this and open it up again. Nope. Okay. Okay. Which pending revert. Confirm file reset. Uh, will I be able to jump back? I need to jump to this specific. I don't remember what I learned in Git about like resetting. Um, which commit are we currently on? It says pending revert. Let's abort revert. Yes. So are we good now? I think now we should be good. I don't want to pull. Actually, I just wanted to check this out, right? I can't. Okay. If I check this out instead, now we are there. Okay. I am gonna have to now find that other commit in order to check out that specific commit. because we are currently now in, because now the head is pointing to, wait, I don't see head anymore. Dude, I don't remember my Git stuff. I'm not gonna bother with this right now. I need to like refresh my knowledge and play around with like simple repos to remember that, and then I'll be able to do this, which is making me realize that this is yet another thing that I should probably be doing more often, as in doing Git stuff more often. But okay, for now, um, we should close this. Let's come here and then come here and okay. So we have initialized our 3 pins. Great. We set all of them to low. And then we set delay. Now, what do we want here? So we are counting. Okay, so we have a number going, right? If I, wait, I need a Python interpreter here. So I forgot the thing with the modulo operator, so let me just remember that again. The number is supposed to be the max range is supposed to be on the other side, right? So if I do 1 modulo 3, I get that. 2 modulo 3 is that. 3 modulo 3 should become 0. Yes, okay. 3 modulo 3 is 0, and then we just wrap around. All right. I need to find a way to assign. This is interesting because I have to work out the Rust way of doing this, but also the ESP32 way of doing that, or specifically the microcontroller way of doing this. I have to think about both. Okay. So if we start at 1, what would 0 give us? 0 gives us 0, right? So if we put these 3 into an array, these are mutable. If I call this function, this is taking a reference to mutable self. So once it is done with its work, it gets rid of the mutable reference, and then I can do my thing again. Or, well, then I can do my thing. Then I can start doing my thing. Sorry, zoned out. Okay, so how do we want to go about this? Let's okay, we cannot have a list. We actually don't need a list. Can the list hold a reference? I think it can. Yeah. So we are gonna do let I don't know, LED array equals array LED O1 LED O2 LED O3. Is this okay? O3. Is this okay? This is okay. So we have our LED array. Oh, wait, we don't need this because the state for all three of them has to be set. Um, the state for all three of them has to be set each time. Yeah, yeah. The state for all three of them has to be set each time. There's set high and set low. Is there like set, can I like specify set level? What's the level here? Okay, so here I think I can use a ternary operator, assuming Rust has that. Um, yeah, give me a second. Let me test something out here. Okay, let a equals I don't know, 1 equals 1, 5, or 10. Is this okay? No, this is not okay. Rust ternary operator. Okay, Rust does not have a built-in C-style ternary operator. Instead, the standard Rustish way to achieve this, achieve the same conditional logic and value assignment is by using an if-else expression. If condition, then so-and-so. Oh, okay. Okay. Um, so my equivalent here would be this. Um, 5 else 10. Equal expressions as operands to so and so. Wait, what? Why is this an issue? Okay, wait, hold on. Let's let's call this B, and let's do let A equals 1. Oh God, what did I do? Let A equals 1. And then here we'll do if A not S, A. Now it's okay. It says unnecessary parentheses. All right, we can get rid of that. Thank you, Clippy. Okay, okay. So once we have this thing going, what I can do is in here, I could set up logic to say, wait, what does the modulo operator return? Let's C equals 1 modulo. Does it return F64 or I32? It's I32. Okay. Oh, it's because these, oh, they'll be rounded off. Okay, yeah, never mind. It'll words. Holy shit. It'll get rounded off. Here, what I could do is put this at the bottom because now I'm not printing this out anymore, right? Here I can say LED01.set level, and level is supposed to be of level type. And then here I do an if condition. Dude, at that point, I feel like No, let me type this out and then let me see which one seems uh hold on, what's the oh, I'm supposed to iterate over this entire array, so I still need the array because I had to assign like an index. So this is not an iterator. And in the ESP32 I can't do. And can I? Can I do an iterator? I don't know. Hold on. I'll find that out later on. For wait, we need an index here. Okay, let's just say for I in what is it? Range 3? Does that work? Range 0 to 3? Is that okay? Cannot find function range. Uh range, is that okay? What was the simple way of doing a for loop in Rust? For, yeah, just Rust for loop. Backup? No, why am I doing that? Oh, there's a good way to set this up. Wait. If we are just using math, actually, I do want to find out this thing. Rust for loop used to iterate over so and so. Okay, that's fine. Oh, that's how you specify a range. For I in this, you don't use the range keyword. You use that in Python. I was just confusing it. So I was going to use this. I mean, I could still do that. I could still do that. So led01 dot set level, and then the condition here is going to be I modulo 3 is equal to 0. Wait, we have to set this as a condition. Yeah. Is this gonna work? I think this should work. I think this should work. Yeah. Um, so if this, then we set level what is it? Level high. Else we set level low. Is that okay? That's okay. Okay, so then we, oh, didn't mean to do that. Oh, why am I doing it in here? Yes, I just remembered why I'm doing it in here. Okay, so then we do this and do this. And here we set this and wait, do I need to do this? No, this is not going to work. What was I trying to do? I was trying to iterate over. So I still need the, okay, you know what? Um, let's just get rid of this. And here I'll replace this with counter. Okay, that's what I want to do. And counter and counter, because I had two different logics in mind, and I'm kind of confusing between the two of them. One of them was going to be this, and the other was going to be to use the for loop, but then I couldn't remember what I was planning on doing in the for loop. Oh God, did the stream freeze again? No, we're good. It's just my video feed that kind of froze, I think. And we dropped frames for a little bit. But yeah, now I think we should be good. And I can set this to be 500 instead of 100 milliseconds. So every half second, it's gonna... What was I gonna how was I gonna be using this LED array? I can't remember that. I had something in mind for this, which was gonna be like iterating over this in a certain way, but then I would still require an index. Oh, I guess hold on. I need to ask Gemini if this is even a thing. Hey, I'm doing no-std Rust coding for ESP32. Are iterators a thing on there? Well, in there. Because I can't remember if iterators were available or not. For lists, for anything heap related, you would need some sort of alloc kind of crate. But wait, we're dropping frames. Oh shit. Okay, hold on. I need to pause this and pause this until everything comes back to normal. Okay, are we good now? Yes, we are good. Okay, so apparently iterators are a thing, which means I could technically do for LED. I don't know what the thing is going to return though. Or I don't know how to get like a tuple for like the index basically. I don't know how to get the index in the for loop. There was a way to get it, but I can't remember. Okay, the answer for iterator is absolutely. In fact, iterators are one of the secret weapons of no-std development on the ESP32. Since the iterator trait and its most common adapters like map, filter, and enumerate. Enumerate is what I was looking for. Okay, okay, so here we're going to do LED array dot, it has to be an iterator, right? This is not an iterator by default. So dot, is it dot iter or into iter? Well, I don't have into iter, so I guess we're just doing, oh wait, I do have into iter dot enumerate. Now the iterator returned yields pairs I and val. So in here I'm gonna be doing I and val. So val is gonna be our LED, which I could just change to that. Val is gonna, or LED. Our LED is gonna be, why is this throwing an error? Oh yes, okay, okay. Hold up. Is this being mutably borrowed at some point? Cannot borrow as mutable? Wait, does this show where? Oh, the scope is not over yet. What if I put this into this kind of thing? Is that okay? That's not okay. Okay, I can comment this out because I wanna try and do this within the for loop. I want to see what that logic was gonna look like. Is this okay now? Now it's okay. Right. So when we are in here, we iterate over all three of them, and then we set the value of, yes, okay, so here we might not need all three. We probably only need one. And I believe, wait, can I call, this is a reference, right? Can I call the function on this? I can. Yes, great. So this is going to be um, if I, which is a U size, I hope I don't have to, uh, wait, how am I going about this? Oh, yes, yes. If counter, um, counter modulo 3 is equal to I have made this unnecessarily complex. Then we return level dot high, I think. Else we return level low. Is that okay? Cannot borrow it as mutable behind that reference. Uh, maybe I need to specify, where did I define it? Here. Maybe I need to specify mutable borrows here. Is that okay? That is okay. Now in here, use of moved value LED array. So maybe this cannot infer type. Is not an iterator. Okay. Okay, this is something for me to explore here because we are running into an issue with the borrow checker. So this is, I'm going to have to explore this on my own later on. Type annotation cannot be inferred. Right. So where, so I think we need the turbofish thing. Where exactly is that required though? Let's try it here, I guess. So it's supposed to be usize and then output. I forgot what type had been given there. I'm just gonna like do this. Okay, turbofish works. Actually, wait, no, I think now we'll find out if it's working. It didn't work. Right. I'll have to fix this off stream. But this should be interesting to look into. This is something borrow checker related that I'm running into. Uh, for now, this should be fine. We'll just set them manually. And if I run this, we should be seeing our LEDs lighting up one by one. Give it a second here. No, it stopped at that. Oh, this is why. Yeah, let's retry that again. This time it should work. Okay, it works. Great. Awesome. So, yeah, dude. Hold on. Let me see it on stream as well. Yes, yes. Okay. Um, we got this working. Now, off stream, I definitely want to look into what the issue was with this. So let me do this because I wanted to do it in this way. This, if you notice the difference here, it's a much more concise way of doing it. So imagine if I had like multiple such LEDs, it would be a much shorter way to iterate over that entire list and and set the values. But okay, in this case, um, so if I do this, right, the first issue was occurring here, I guess, and when we are iterating over something, generally, and I keep forgetting this. I need to do more Rust programs, otherwise I'll keep on forgetting this part. Fortunately, the Rust compiler is there to tell us that hey, you can't do this. Um, but yeah, I need to remember that these various blocks, um, we are essentially moving something. We are moving the value into these blocks, and once the blocks exit, the value is gone. So you don't want to move. You want to borrow. However, does it have to be a mutable borrow? So I need to explore this because this this is where we get into a situation where we need the turbofish syntax due to like all the generics going on. But are there any other ways to do this? I should look into that as well. Because I ran into an issue here. It doesn't mention that it has to be mutable. I guess I need to trace this back to understand what exactly this is doing. Because into iter takes self. No, no, no. I remember this. I remember looking into iter. I don't think it consumes, even though it says self, it doesn't say reference to self. I don't think it consumes it. There was a certain there was some specific reasoning that Gemini had given behind this, that even though it says okay, arrays have special behavior when calling into iter prior to so and so. Okay, the array cannot be used after calling this unless T implements copy. T in this case is our type of that item, and then n is the number of those items. T is output. It's a mutable reference to that. And if it's an array, so this is why it's telling us for this, right? And then it says creates a consuming iterator. That is one that moves each value out of the array. The array cannot be used. Oh, okay. Okay, that's going to consume the entire array. Dude, if that's the case, then I guess. Wait, are we using the array at all later? Actually, no. Wait. Here's what we can do. In the loop, we'll create the array. here, and we'll comment this out. Okay, right. Um, you're joking. I just had to make it mutable. Why does it have to be mutable though? Because I mean the items in it cannot be touched. Does the array have to be mutable because the references inside are mutable? Or sorry, does the array reference have to be mutable because the references inside are mutable? Because you cannot mutate an array as far as I... No, wait. You can't change the size of an array, but you can mutate an array. You can probably change the values in place. Okay, yeah. Yeah, no, my bad. I forgot about that. Because otherwise an array would be kind of useless if you could just create the collection and then not do any not make any changes to it. Okay, keeping that in mind, would this still work? Hold on, where is it? Here? No, it doesn't work. It doesn't work because of the moving thing. It's moved due to this method call in the previous iteration of the loop. Okay, yep. Okay, so we come back here and this becomes mutable. And then now, just for the sake of showing some difference, we'll take this back down to 200 and compile this again. I think I've got my logic right. And we have, if I've got the logic right, then I've shortened this block of code down to this block of code. Okay, so let's close this and run, and now give it a second while it loads up. Yes, okay. So now you can see the timing has increased on the LEDs. We can make it a little faster. Let's say 50. Almost there. Yep, there it is. That is quite fast. So now you can see there's definitely a difference there. Now actually it's so fast that it doesn't really... Hold on, let me increase that speed a bit. Okay, I think that's a bit better. Okay. All right. Oh, uh I'm just noticing this. My bad. Uh Jim, thank you for the follow 2 hours ago. That's my bad. I somehow this didn't show up. Um yeah, my bad. Okay. Thank you for the follow. I just looked at my stream manager and noticed the follow in there. Okay. Now, um, just a second. Now, you know what? Okay. All right. So, I think that's going to be it for today's stream. We made some good progress today, and I'm happy with the progress that I've made, and I'm looking forward to doing more of this tomorrow. I need to set up one or two potentiometers so that we can do the Arduino example tomorrow, the first Arduino example tomorrow, and yeah, dude, we finally have had our very first BREADCAM stream. The last, well, the last, let's say, IRL cam stream, webcam stream that I had done was a good, I don't know, 5+ years ago. One of my very first streams on Twitch was, it was an IRL cam stream, not a face cam stream. It was me soldering, doing some soldering work for an LED strips project that I had. Basically, I was just doing soldering stuff. I don't even remember if it was for the LED strips project or if it was just me soldering for like creating jumpers for myself. Back then, I was doing that. I would create jumpers out of like hanger and well, use hanger for the pin. Not hanger. I think it was some other type of wire. I don't remember. I think it was called galvanized wire, maybe. I don't remember. But yeah, I used to make jumpers for myself. They were horrible for like connection, but they gave me good soldering practice. Now I use proper jumpers, but back then I used those jumpers and I created those jumpers just because I needed an excuse to do soldering. But yeah, dude, I'm I'm happy. I'm happy that we finally started doing ESP32 stuff with webcam, by the way, with webcam on stream. Um, I had to set this up real quick. I had to do a bunch of experimentation like shortly before the stream, and I'm happy that everything worked out just fine. I was even able to get the settings that I wanted just right, and I don't even think I need to experiment with this anymore. I'll still experiment with it like later on. For now, I need to like close a bunch of things on my Ubuntu desktop to let the CPU cool down a little bit because I don't know if the sound is coming through on stream, but like the fans have been one fan. The fan has been going off for a while. It's been getting loud for a while. That being said, holy shit, we are officially doing ESP32 Rust streams. Um, so now this is yet another one of the things that I'm going to be doing in terms of streaming. This is going to be yet another one of the streams that we're going to be having. The other one being, you know, working on the content pipeline and doing like Polar stuff and doing deep learning stuff. But this is exciting as well because I've been meaning to learn all of this stuff as well. I need to I need to explore this whole thing again. The specifically the into iter thing. And in fact, I think I'm gonna explore this outside of this ESP32 Rust project. I think I'll just create a bare bones Rust project and explore the thing there because this is, I believe, where Turbofish becomes useful. Though, if it was useful, then how is it that I was able to just do this and that was okay? Maybe Turbofish wasn't the requirement here. Maybe it was just the fact that it needed to be a mutable reference to the array and not, you know, completely moving the array. Or maybe it was two different issues. One was moving and the other was that it wasn't able to infer the type. I don't know. I'll see. I'll experiment with this off stream. I don't think I'm gonna raid anyone today. I'll just end the stream, and I have to go cook in some time as well. Yeah. So tomorrow's stream is also going to be yet another ESP32 Rust stream. Let me explore this off stream, understand what the issue was, and regardless whether I understand it or not, we're going to continue with the other stuff tomorrow. We are probably going to be exploring serial communication. Oh, serial communication. Yeah, I had to look into the named pipe stuff. I forgot about that. I should do that off stream today. I should look into that off stream and make sure I'm able to read the data, just so I can pipe it into something if I need to. But yeah, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.